Throughout the history of life on Earth, some creatures have been so big, so bad, or so creepy that just imagining an encounter with them is enough to make your skin crawl. While nowadays, most people already dislike ordinary insects, can you imagine what they looked like millions of years ago? Some of the insects that lived back then were far larger and a lot more dangerous. And that's exactly what we show you today. 15 most dangerous insects you're glad are extinct. So, let's start off with number 15, Gigatitan. The Gigatitan was an enormous insect that lived during the Permian period, which occurred 298 to 252 million years ago. This era saw some of Earth's most drastic changes, including the emergence of the supercontinent Pangaea. The period also ended with a mass extinction that wiped out around 96% of marine species and 70% of terrestrial ones. Gigatitan was a carnivorous, now extinct insect with a wingspan of 28 inches or 71 centimeters. It had broad wings reinforced with a dense network of veins that added strength and stability, all attached to a muscular thorax that also supported the insect's powerful legs. Interestingly, Gigatitan wasn't a true dragonfly, but belonged to a group of insects called meganeura. These were some of the largest and most aggressive predators of the Permian, capable of catching and devouring other insects, as well as small reptiles and amphibians. Imagine how terrifying it would have been to encounter one of these guys if humans existed back then. Number 14. Dinocraton draculae. The Dinocraton draculae, aka Dracula's terrible tick, was an enormous extinct tick that lived during the Cretaceous period, roughly 99 million years ago. It was officially identified in 2014 when a fossil encased in amber was discovered, preserving the tick in exceptional detail. The species earned its Dracula-inspired name due to its long, piercing mouthparts resembling fangs. Like today's ticks, Dinocraton draculae fed on the blood of other animals. While it's still uncertain what exact creatures it targeted, scientists believe it may have fed on dinosaurs, since feather remnants from a dinosaur were found within the same amber specimen. What makes this tick particularly fascinating is its unusual mouth structures. Unlike modern ticks that use blade-like mouthparts to cut through skin, this one had long, barbed projections used to pierce its host's skin. This suggests the tick may have latched onto its host using a completely different technique compared to modern ticks, making it a unique bloodsucker of its time. Thanks it's not anymore. Number 13. Mongol-arachne. It was one of the largest spider species to have ever lived, with a leg span reaching up to 6 inches or 15 centimeters. For comparison, most modern spiders only measure a few inches across. This big arachnid roamed the Earth during the Jurassic period, around 165 million years ago, a time known for tremendous evolutionary growth in both plant and animal life. This is just one example of the astonishing biodiversity of that era. It was a predator, and likely fed on small vertebrates and other insects. Thanks to its size and strength, it could overpower prey larger than itself. Scientists think it lived in underground burrows, which could be as deep as 3 feet or 1 meter. These burrows may have provided shelter from larger predators and protected them from environmental threats. If you already shiver at the sight of regular spiders, you're probably more than relieved that this massive spider species no longer exists in today's world. Number 12. Megalograptus. The Megalograptus was one of the earliest documented predatory arthropods, and we don't know how, but it played a vital role in shaping primitive marine ecosystems. Megalograptus was a species of sea scorpion that existed during the Silurian period, about 430 million years ago. It was a type of aquatic predator that lived in shallow seas and reef habitats. It was also one of the largest arthropods of its time, growing up to 40 inches or 1 meter in length. In addition to its elongated body, It had a pair of massive claws up front, which it used to grab and crush its prey. It also had long, thin legs that helped it move through the water. Its body was protected by a rigid external shell that offered defense and structure. One of the most fascinating features of Megalograptus was its respiratory system. Instead of gills, it extracted oxygen from the water through small, plate-like structures on its shell. That feature made it biologically unique. Number 11. Manipulator modificaputus. This is an extinct species of cockroach that lived during the Cretaceous period, about 100 million years ago. One of its most distinctive features was its extended forelegs, which scientists believe were used to grasp and manipulate objects, hence the name manipulator. This adaptation is entirely different from what we see in modern cockroach species and points toward a highly specialized way of life. Based on its physical structure, researchers suggest it likely lived in an environment filled with thick vegetation and natural obstacles. Another fascinating trait of this species was the altered hind leg, which may have functioned like an antenna, giving the insect extrasensory awareness of its surroundings. This feature hasn't been seen in any other known cockroach species. As such, the discovery of this insect offers significant insights into the evolutionary history of cockroaches and the ways they've adapted to survive in a range of environments for millions of years. One reason they remain incredibly resilient creatures today. Number 10. Anomalocaris. This was a big invertebrate that could grow up to nearly 16 inches or 40 centimeters in length, not including its front limbs and tail fin. This creature lived roughly 500 million years ago during the Cambrian period. It had a pair of large compound eyes and rows of swimming flaps along its body. Anomalocaris was one of the largest predators of its time and had a very unusual method of hunting prey. Its front limbs were equipped with spiny hooks used to seize prey, which was then brought to its sharp-toothed, circular mouth to be crushed. Scientists believe this creature was an active hunter. Initially, Anomalocaris fossils were mistakenly identified as belonging to 3 separate species. However, it had a distinct way of moving, using its swimming flaps to propel through the water in a snake-like motion. Anomalocaris was among the largest animals of the Cambrian and is thought to have been a top predator, although it too was preyed upon by similar species. Number 9. Arthropleura. Arthropleura was the largest millipede to have ever lived, capable of reaching lengths of 8.5 feet or 2.6 meters. This colossal invertebrate thrived in the coal swamps of what is now Scotland and North America during the late Carboniferous period, approximately 300 million years ago. It was a herbivore, feeding on plant material and decomposing vegetation found across forested regions. Its strong jaws allowed it to chew through dense plant fibers, much like modern-day grasshoppers and beetles. Despite its intimidating size, Arthropleura was not a predator and posed little threat to larger animals. Its primary defense likely came from its robust armored exoskeleton, which offered protection against environmental hazards and potential threats. The cause of its extinction is still under discussion. Some researchers suggest shifting climate and vegetation patterns during the late Carboniferous played a role, while others point to the rise of more complex ecosystems and the emergence of new apex predators that gradually forced it into decline. Number 8. Megarachne. When Megarachne was first discovered, it was misidentified as a giant spider. Later research confirmed it was actually a type of sea scorpion called an eurypterid. Eurypterids are an extinct group of aquatic arthropods that lived during the Paleozoic era, which spanned from 541 to 251 million years ago. The Megarachne species was initially found in the 1980s, based on a fossil imprint found in Argentina. Further studies helped scientists learn more about this animal. It's believed to have lived in shallow seas, using its powerful claws to trap and kill prey. One of its most notable features was its size. Early estimates claimed it had a leg span of around 13 feet or 4 meters, though that number was later disputed. Even with revised measurements, it remains a crucial species for study. It offers valuable insight into the evolution of arthropods, especially since eurypterids like megarachni were among the earliest known forms of their kind. Number 7. Pulmonoscorpius kirktanensis. Pulmonoscorpius is an extinct species of scorpion that existed during the early Carboniferous period, approximately 330 million years ago. It ranks among the largest scorpions ever found, with the biggest specimen measuring more than 28 inches or 70 centimeters in length. Fossils of this colossal scorpion were first discovered in the Kirkton Formation of Scotland. Remarkably, some of its soft tissue was also preserved, giving scientists rare insight into its internal anatomy and potential behavior. Pulmonoscorpius is believed to have lived in both aquatic and semi-aquatic environments, such as rivers, lakes, and swampy regions. It was a formidable predator that used its massive pincers and venomous sting to subdue prey. One of its most distinctive traits was its ability to breathe air, making it one of the earliest known scorpions to possess lungs. This adaptation likely helped it thrive across different terrains and made it more versatile than many of its contemporaries in the Carboniferous ecosystem. It was cool. Number 6. Cambroraster falcatus. Radiodonts like Cambroraster are often referred to as sea monsters because of their bizarre and alien appearance. Cambroraster is an extinct genus of hooded radiodonts that lived during the Middle Cambrian, approximately 505 to 510 million years ago. This particular insect is a monotypic genus, meaning it includes only one identified species. Its name is inspired by its distinctive claws, which feature parallel blade-like structures used for grasping prey, likely evolved to navigate the dense ecosystems of Cambrian seas. This marine species belonged to a group of arthropods that were once among the ocean's most dominant and versatile predators. They were known for having unusual and highly adapted anatomical traits, including spiked appendages and segmented limbs. While many were ferocious hunters, some species fed only on small invertebrates or plankton, while others scoured the seafloor for remains. Number 5. Meganeuropsis permiana. Meganeuropsis permiana was among the largest insects to have ever existed, with wings stretching over 27 inches or 70 centimeters. In comparison, today's largest dragonflies only span about 7.5 inches or 19 centimeters. This ancient predator soared through the skies during the Permian period, approximately 275 million years ago. It likely fed on smaller insects and even tiny vertebrates, using its powerful jaws to snatch and subdue prey. Its sheer size and strength probably also helped deter potential predators. Adapted for aerial life, Meganeuropsis had massive translucent wings and a lightweight body, though its enormous size may have made prolonged flight difficult. Many scientists believe it may have relied on gliding for longer durations. Like countless other species, it vanished around 252 million years ago during the Permian-Triassic extinction, the most catastrophic mass extinction event in Earth's history. Number 4. Trilobites. Trilobites were among the earliest animals to evolve eyes, with certain species developing remarkably complex visual systems. These creatures were part of the most ancient arthropods and dominated both shallow coastlines and deep-sea environments. Trilobites existed from the early Cambrian through the end of the Permian, approximately 520 to 251 million years ago. Their diversity was extraordinary, with more than 20,000 documented species in the fossil record. Their bodies were segmented into 3 key regions: the head, thorax, and pygidium, with their legs attached to the thoracic section. Despite their evolutionary success over hundreds of millions of years, they became extinct around the same time as the dinosaurs. Their disappearance marked the end of an era for one of Earth's oldest and most successful marine groups. Their fossils remain crucial for understanding early life on the planet. Just imagine how many bizarre and terrifying insects once roamed Earth. We should be glad. Number 3. Paleotic. Paleotic were a group of massive, now extinct flying insects that flourished around 300 million years ago. These prehistoric insects were characterized by their broad, flat wings that stretched several inches or centimeters and were supported by a dense web of veins. The most prominent members of this group were part of the meganeura family, which included some of the largest known flying insects. Their wingspans could exceed 20 inches or 50 centimeters. They were likely opportunistic feeders that consumed a wide range of food, including plant material, small invertebrates, and possibly even other insects. Their wing structure allowed for efficient gliding and quick, agile turns, making them skilled aerial hunters. Paleotic are particularly significant in the study of insect evolution because of their unique wings, which differ structurally and functionally from those of modern insects. Eventually, like many prehistoric species, they went extinct between 300 and 250 million years ago, likely due to a combination of environmental changes and ecological competition. Number 2. Aptenoparissus bermanicus. Aptenoparissus is a genus of extinct wasps that includes 8 documented species and is the only known genus in the Aptenoparisidae family. What makes these wasps stand out is their unusual appearance, like a mashup of an ant, grasshopper, and wasp. Thanks to a remarkably well-preserved fossil specimen, scientists have been able to study the insect in great detail. The fossil revealed a detailed head structure, although the abdomen was flattened during the preservation process. The wasp is believed to have had a slim body with a distinct neck-like extension. It also featured a long head with large compound eyes, extended antennae, and strong jaws. Its wings were transparent with visible veins and fine hair, while its long legs resembled those of a grasshopper. The fossilized insect was female and lacked wings. Experts think it lost its wings over time due to thick vegetation in its habitat, but these are just theories. Number 1. Titanomyrma. Titanomyrma, aka the giant ant, was a prehistoric insect that lived during the Eocene epoch, about 34 to 56 million years ago. It was one of the largest ants ever recorded, with a body length reaching up to 2 inches or 5 centimeters. It's believed to have been a dominant predator in its environment, preying on other insects and even small vertebrates. There were 2 species of Titanomyrma, Titanomyrma gigantea and Titanomyrma similima, though the gigantea was notably larger and more aggressive. This giant ant had a distinct jaw design, perfectly suited for capturing prey, and may have had a venomous sting. Its large size is thought to be linked to the elevated oxygen levels during the Eocene, which allowed insects to grow far larger than they can today. Despite its intimidating build, it was still a cooperative and efficient member of its colony. Scientists believe it functioned much like today's ants. What do you think? If you've enjoyed this video, please like and subscribe. Thanks for watching. We'll see you soon.